without further ado, though, I think we're good to get going with Valerio. So I'll pass it on to our first speaker.
Hi, so hi everybody, and thank you very much for having me here. So first of all, I'm going to share my screen. Unfortunately, we tried out my audio, but it doesn't seem to work properly. So I'm just gonna pass you like the links so that everyone like in the chat, I mean like not in the chat, but everyone in the audience can actually like just like follow what I'm like talking about, like when I'm trying to show like some stuff like audio or videos as well. Okay, yeah, so in this presentation, I just want to give you a little bit of an overview on generative music, or in other words, generating music with artificial intelligence. And we're going to look into a bunch of different things, but before that, just like a couple of words regarding like myself. So I work like as an AI audio and music consultant, and I'm the host of the Sound of AI, which is like this cool ecosystem with all things about music, AI, audio AI, and sound AI. And I have a background as a musician, classically trained, and as a scientist and programmer as well. Now, onto the talk itself. So these are the different points that I'm going to be touching upon. First of all, we're going to be starting from the difference between intelligent and creative tasks. Then we're going to move on, zooming into generative music or music AI, creative music AI, really. And then I'm going to give you a brief history of generative music and try to give you sort of like a timeline of what's happened over the last 60 years or so. In generative music. And then I'm going to show you some sample generative music systems. And as I said, unfortunately, I won't be able like to show you like the audio directly from my presentation. I'm going to just like share the links with Josh and the others so that they can give access to those links in the chat for you. Then I'm going to discuss some of the challenges that we are currently facing in generative music, and talk about the sort of like business impact of AI within the music production, musical landscape. And finally, this is not related to the presentation itself, but I'm going to introduce super quickly the Sound of AI Accelerator, which is one of those initiatives within the Sound of AI ecosystem. As you can guess, this is a music AI accelerator within the Sound of AI environment, but I'm going to tell you all about this like later on. Okay, let's get started. So first of all, we want to start from the difference between intelligent and creative tasks. So here we have sort of like trying to do image classification or even object detection in this case, right? So you have an AI that analyzes, processes an image, and it tells you, okay, so we have a person here, we have a statue here, we have a flag over there, right? And this is like an intelligent task because we have an artificial intelligence that has an objective way of sort of like understanding whether like what it is doing is correct, the answer that it gives us, like it's correct or it's not correct. The same thing like can be said for like a robotic arm, right? So we may use like some AI algorithms to let like this robot arm do really cool things, perhaps like create a statue like by itself, or like something creative like that, or something like very, very specific, like sort of like, I don't know, like building a car or something like that, right? And again, this is still like an intelligent task that we can program, or we can use an AI to do like this kind of stuff. Another like example of an intelligent task is speech recognition, right? So you have an algorithm that can take whatever you say and then translate it into text. And we have a gazillion examples of speech to text. And now like these systems tend to work actually quite well. Now, what characterizes all of these examples like that I just showed you is that like there are sort of like objective success metrics. So we as I said, like in the case of object detection, we can say whether like a certain object within an image has been classified correctly with speech recognition. Of course, like we have a ground truth, which is just like the thing that the person has said. So we have an objective way of assessing whether like we have a success or we have failure. Of course, there are gray areas for sure, but all things considered, we have a ground truth and an objective success metric that we can use to iterate upon in order to improve our algorithms. And another point about these intelligent tasks is that they're well defined in the sense that the problem description can be formalized, right? So there is like a formalized way of like kind of like thinking about speech or thinking about objects or thinking about the different ways like a robot can move like within space in order to build something. Now let's move on to something different, to creative tasks, like for example creating a symphony or creating a painting. Well, in this case we don't have an objective success metric. And this is a big problem, right? Because in order for artificial intelligence to advance, or like any type of venture really to advance, you want to have an objective success metric so that you can iterate upon that and improve based on something that you want to optimize. But how can you optimize a symphony? How can you optimize a painting? That really doesn't make too much sense because there's a lot of subjectivity involved in the way we evaluate this type of artifacts, creative artifacts. And also for creative domains, we are talking about domains that are very difficult to formalize. It's very difficult to formalize music or to formalize literature, right? So because of those reasons, there's like a substantial difference between sort of like trying to address intelligent tasks and creative tasks. So artificial intelligence has like a gazillion different definitions, but one of like the main ones is this idea of like building systems that can do rational things. It can do like intelligent tasks using like rational means to achieve the best results possible. Now, computational creativity, we can think of as something slightly different, and we can think of it as a branch of artificial intelligence, which is focused on the idea of building creative machines that can create artifacts that may be deemed as creative by human beings. And so in computational creativity, we try to create or to develop systems that show some degree of creativity, or at least can generate artifacts that we as humans would deem as creative. Okay, so this was sort of like my obsession, and has been my obsession for the last 15 years, really. And this building in particular is where some of this like obsession like took place initially, at least, like when I was doing a PhD here. This is the University of Huddersfield in the UK, and that one there, it was, at least like at the time, my PhD room, where I was sort of like thinking about like these questions. Can machines be creative? Can I reproduce in silico how humans compose music? And how can we formalize the compositional process? And so this sort of journey brought me into generative music and allowed me to sort of like combine the biggest passion that I have. So music on the one hand, and science and programming and artificial intelligence on the other. Now, let's think about generative music itself. So what is like generative music, and what are like the challenges that we have with generative music? And so here I'm trying to give you like a few of like the most important challenges really that we have in generative music. So how can we define or represent music? how can we evaluate generated music? So as I said, there isn't really an objective way of evaluating the quality of the music generated. Also, who should evaluate generated music? Is it experts? Is it like the lay person, or is it other machines, perhaps, right? So these are very difficult questions, and there are loads of like lines of research open still today to try to address some of this. Now, generative music is a sort of like very interdisciplinary field. In order to work within generative music, of course, you need to know about artificial intelligence, because of course you're going to leverage many of the techniques and concepts that you have in AI in order to create music. But you also need to know about music information retrieval, because there's a tight connection between analyzing a piece of music using algorithmic techniques or computational techniques, and that is basically the goal of music information retrieval. And on the other hand, analysis is connected with generation. You need to analyze and understand music in order to generate it in the best way possible. But of course, you also need to have an understanding of digital signal processing, especially if you are generating music within the audio domain, which is like one possibility, as we'll see in the remaining of this presentation. You need to know about software engineering, of course, because these systems can become super huge, and you need to be a really good programmer in order to write like code that's reliable and that's scalable at the same time. But you also need to know about music cognition, because if you can leverage that domain-specific knowledge, you're going to be able to steer your programming, your AI skills in a way that makes more sense, and you're going to be able to create better music. And finally, but of course, last but not least, is music theory itself. So you need to have at least a working knowledge of music theory in order, once again, to direct your algorithms in a way like that makes the most sense possible. Okay, so now let's take a look at how we can classify different generative music systems. And there are many ways we can classify them. So first of all, we may ask, what's the goal of the system? So it could be for generating just melody, or for generating chord sequences, or perhaps to create an entire full track, or improvising a jazz line or blues line, or creating loops. But at the same time, the goal of the system is also in relation with the type of music that it generates, right? So you may have a system that generates music for video games, or for movies, or for ads, or absolute art music, or concert music. Another way of classifying these type of systems is to look at the final users. And here we have a lot of different types of users. So some of these systems may be tailored to songwriters, others to composers, perhaps to developers or researchers, or even consumers and users who can play around with them to create their own customized music. Another way of classifying these systems is to ask ourselves, how's the music generated? So what are the techniques that we can use to generate that music? Again, another way of like classifying this system is to ask, how is music represented? And regarding music representations, there are like two sort of like major ways of working with generative music. One is the so-called symbolic approach. The other one is the raw audio approach. I'm sure like most of you will be familiar like with symbolic music representation, and basically what we're talking about here is using symbols to represent music, symbols that map onto music events. And it could be that you may end up working with a piano roll representation, basically where on the x-axis you have time, while on the y-axis you have frequency or pitch. And so each event within this 2D space basically represents an event of a certain pitch at a certain point in time. But you can also use MIDI or music XML. So all of these are symbolic representation of music, and you can use them to work and train your models in. But there's also another approach, which is the one which is quite trendy right now, and it basically works directly with the signal itself, with raw audio. And the idea is that the moment you work with symbolic music generation is that you have a model, if you're using some sort of machine learning or deep learning, and you train the model with these symbols, and hopefully the model will learn some patterns, and then as inference time, it could be used to generate other symbols that then can be interpreted as music. Whereas if we are in the audio domain, what happens is that we pass in directly audio to a machine learning model, and then we expect audio on the output side. So you would expect directly audio that's generated. So you already get like the music completely as a self-contained package, right? Of course, like there are like ups and downs, or like upsides, like and downsides, basically, in working with symbolic music versus like raw audio music representation, right? In the case of symbolic music, the great thing is that it is like very low dimensional, so it's easier to work with it and for the models to understand larger structures, larger musical phrases and structure, as I said. Whereas in the case of audio, the big advantage is that you're going to be able to directly encapsulate all of those effects and manipulation of the audio signal that in the case of symbolic representation is just impossible to encapsulate because they're completely overlooked, because they are not part of the symbolic representation, which mainly focuses like on pitch, rhythm, and different instruments, but in a very abstract manner. Okay. So the other sort of like question that we had was like, how do we generate music? And I mean, we've used over time all sorts of techniques to generate music. A lot of symbolic AI, like expert systems or generative grammars, and so on and so forth, but also machine learning and deep learning, which has become especially trendy over the last few years, but also like other statistical methods like Markov models, hidden Markov models, but also like very like algorithmic approaches, like using fractals, cellular automata, and even evolutionary algorithms. So basically, everything you can find within the domain of the field of artificial intelligence, one way or another, has been used to produce music in some shape or form. Cool. If you want to learn more about like all the different like things that have happened over time in terms of like generative music, I suggest you two papers. This one, like the one on the left, AI methods in algorithmic composition, is a great paper to understand a lot about all the more traditional approaches, more like on sort of like statistical symbolic AI side. Whereas here on the right, we have a paper that mainly focuses on more advanced approaches using mainly deep learning techniques. So just like take a screenshot, like if you are interested in this, like these are very, very interesting papers, just like to take an overview of the overall field. Cool. Now let me give you an overview of the timeline of generative music as a field. And I've tried to sort of like divided it into different sort of time ranges, if you will. And the first one is probably like, it's absolutely like the longest one, and it runs from mid-50s all the way to 2010, and that is the academic niche. So at this point, most of the work in generative music has been done in academia, and it was a very niche sort of like subfield of at the crossroads of AI and computational music, computer music, if you will. Then in 2010, we had the advent of a lot of generative music startups, which tried to use many of the stuff like that came out like during like the academic niche period and implement them to create products that people could actually use on the market. And then from 2016, we have big tech coming in and experimenting with generative music. Now, let's zoom into each of these periods And I'm going to give you like some examples of like the different like systems that have been built like throughout like this period. So during the academic niche, as I said, there has been a lot of experimentation, a lot of incremental advancements, but most of the time, academics would focus mainly on parts of tracks. They wouldn't generate like the entire track, but rather focus on smaller scope tasks, like for example, generating chord progressions, doing some accompaniment, or generating a drum line. Then there wasn't really any focus on audio production quality at all. It was mainly in the symbolic part. So the results aren't really that impressive from a production perspective, but there are impressive results indeed from a compositional perspective. The main problem that we had throughout this period, it is like that the community was really scattered all over the place. We had somebody working from computer science, someone else coming from computational musicology, someone else from music cognition. So there really wasn't a community and a forum around which the community could gather. So this was like one of the main disadvantages that throughout like this initial period. So if you're wondering where it all started, from what we know, that is in 1956, when we had a couple of computer scientists who worked on this suite that's called the Illiac Suite, which is a string quartet. And if I remember correctly, like this compositions is divided into 4 movements, and within each of the 4 movements, these researchers use different techniques like Markov chains, generative grammars in order to generate a music score. So I'm just going to move on. You folks can just like listen to the composition while I'm going on. Okay, so here in 2003, we have Continuator, which is a super interesting piece of software developed by François Pachet, a French researcher who's been like really on the forefront of generative music for a very long time. And now he's working for Spotify, I believe. And so this system is based on Markov chains, and it's really interesting because it is able to improvise with you. It listens to whatever you play, it understands what you play, and then it answers. So you create this level of statement and answer, and this continuous improvisation, bidirectional improvisation with the machine. And the result is actually quite cool. So now we jump on to 2015, and this is the one of the outputs of my PhD thesis. I built this system that's called S of S of S, and it stands for, it's an acronym that stands for Simulation of Society of Songwriters. So this was a really cool project that I worked on. So basically the idea is to create a society of songwriters where each agent composes and shares music, and the agents evolve their compositional style based on the musical taste of the other agents. So as you can see, like throughout like all of this period, this academic niche period, there's a lot of experimentation, and but none of this really is part of like to build a product that can be put on the market. And this happens for the first time in a kind of like serious manner around 2010, when we start having the first generative music startups. Throughout this product, throughout this period, from 2010 until 2016, I would say, like we have a lot of generative music startups that pop up, and the focus is mainly on products. They mainly focus on full piece generation, and there's, for the first time, there's a lot of attention put on the high quality of the audio generated. And it's the first time that we start having like quite good music data sets as well for generative music. And there are a lot of startups that start relying on machine learning quite heavily. So here you have some of those startups, and some of these startups like exist today still, like Andal, Amper Music, I think like it was bought at some point, but Ava Music and Moobirds are still around. I co-founded Melodrive, and that was in 2016. And so what we did back in the day was creating this cool music engine that could generate music in real time for video games. And the sort of like really cool thing was that the music would adapt to the emotional context of the video game into the narrative. So we shipped a Unity SDK, so an SDK for the Unity game engine, and so that was used by indie game developers. And again, at Melodrive, we also came up like at some point like with cool sort of like prototypes and stuff like that. And one of this like was this Kantor project, which was an artistic VR experience where you had the audio visual components of it, which were both generated in a kind of, in a generative manner. And so the whole thing was based on the paintings of Kandinsky, really, and you could jump like from one island, which was sort of a 3D rendition of a painting of Kandinsky, to another one, sort of like teleporting. And so here we also published an album with some of the music generated, and it's on Bandcamp, and you can listen a little bit like to what we came up with. So now we move on to the sort of like the third period of this timeline, which is big tech experiments. So this starts around 2016, and here we start seeing that there's a huge shift from traditional machine learning techniques towards deep learning. We see the use of massive data sets, massive computational power in order to create these models. And these experiments really don't have a commercial end goal, at least for now, for these big companies. And when I'm talking about like this big tech company, I am referring to Google and its sort of like creative AI research lab called Magenta, OpenAI, Amazon, IBM, through Watson. And there have been a lot of experiments throughout like this period, one of which is MusicVAE, which is a really cool system that has been developed by the Magenta research group within Google. And this is a model that uses variational autoencoders in order to create like cool melodic patterns and to move from one melodic pattern to another melodic pattern in a kind of smooth manner. So let me share once again. Okay, and in this video, you can hear that we basically have a couple of melodic ideas. The first one here, at least like I think like you can see the video, that was the first one. This is the second one, and then throughout the video, you'll be able to see how the model is able to move smoothly, like from the first melodic idea towards the second melodic idea. So it's a really, really cool model all around. Now, we also had AWS Deep Composer released by Amazon in 2019, and this came out as a way, it wasn't really like a product per se, and it came out in a hardware form. I think like they also like were selling keyboards just like to play around with the model in an interactive way, but it wasn't really a product per se, but rather a way for Amazon to showcase how cool deep learning, machine learning can be, and the different like potential that it has. And so that like developers could actually like play around with it quite a lot. And then in 2020, we had Jukebox, which was released by OpenAI. And this is like something like quite revolutionary, I have to say. It generates directly from raw audio. It uses a more sophisticated version of a variational auto encoder that's called a VQVAE. VQ stands for vector quantization. This model is really, really interesting. Let me share this screen here. I'd like to share this link once again. And it's quite impressive because this model is able to capture not just the music style of a certain artist, for example, Frank Sinatra or Elvis Presley, but also to generate the voice of these big artists. And it's quite uncanny to listen to the music generated by this model. It has a lot of problems, like for example, it's not capable of creating a convincing overall structure for the music, and at the same time the audio quality isn't really there. It's not really that high fidelity, and it has a lot of artifacts, but still it's quite impressive, the overall result. And now I just want to inject like this work like that I did with the Sound of AI community. And of course, like it's not big tech, but it's something like that we did in 2020. And I think like it's quite relevant for the competition that you folks have right now. So we basically built like this neural synthesizer, which could be activated with voice commands. Now let me share once again the link here. Yeah, I'm really sorry for this inconvenience, but I hope it's not too disruptive. Okay, so this was a community-driven research project. So we had more than 150 people sort of like joining and working on this project at different times. It lasted for 1.5 years. People from all sorts of backgrounds and kind of like levels of expertise, which worked together, and we were able to build this cool neural synthesizer with voice commands. This is like the link that I shared, and so here you can see a lot of different examples of the one-shots that were actually generated using these commands. Like for example, give me a bright guitar, soft acoustic sound, and here you can down here you can also hear when you stretch the capabilities like of this synthesizer, that it generates one-shots like that are quite weird, like all around. And all of this research went into a paper that we published last September in AIMT, which is the conference on artificial intelligence music creativity. Cool. So now we move on to perhaps the final period within this timeline, and I still don't know if this is going to be a new period, but I believe it will be eventually, and I call it the acceleration. And the reason why I call it the acceleration, because I'm noticing that there's a lot of buzz around generative music, generative audio at this point, and I think like that the technology is literally exploding. So we are in the meat of a generative AI revolution. So we all know about ChatGPT, text-to-image generation, like Midjourney, DALL-E 2. And we are at a point where we also start having text-to-music generation, which is a relatively like simple task to understand. So you come up with a piece of text, like for example, a fusion of reggaeton and electronic dance music with a spacey, otherworldly sound. You have a music model, and you end up like with a piece of music that tries like to implement your textual input. Now, there have been quite a lot of models coming out like that do this. For example, one which is like quite famous is called Refusion, which came out, I think it was December last year. So it's a couple of months, 3 months. Okay, let me share this one. Okay, and this model uses diffusion models. Specifically, it was starting from stable diffusion, but then a frozen version of stable diffusion, but then it was fine-tuned on some spectrograms. But we also have other approaches. For example, MusicLM is a quite stunning model. It's based on sort of like sequence to sequence representation. So basically it uses like transformers, and it's a quite complex model because it's made up of many other models. And I have a kind of like quite in-depth explanation of this model, which came out probably 3 weeks ago, something like that, on my YouTube channel, in case you are interested. But the results here are quite impressive, I have to say. By any means, they're perfect, of course not, but they are quite the leap forward, I have to say, all around. And you can just like go to this page and just like try out like some of the of this kind of like music implementations like for yourself. Okay, so when I'm saying I think like we are entering a period of acceleration, is because only in January of this year, so last month, we had, I don't know, like probably then 10, 15 papers with amazing models. And here I just like list 4 of them: MusicVAE, Audio, LDM, SingSong, Rave 2. And it seems like that it's kind of like building up interest like for generative music is building up. Generative music or generative audio more in general is building up quite fast. And it seems like that point in time where not only you have the interest, but at the same time, the technology is there. It's almost there, so that all of this cool tech could be transferred and made into really cool products. But we still have, of course, a gazillion challenges, and music composition hasn't been solved by any means in using like computational ways. So some of the problems. Long-term structural music coherence is still a huge problem. There isn't a single model of the ones that I showed you up until now, which is capable of creating a full piece of music which may be coherent with a structure, with ebbs and flows of tension, and the typical kind of coherence that you get from human-generated, human-composed music, right? The audio production quality is still a big problem. MusicLM has improved on what we had before quite a lot, but still the high fidelity isn't really a thing. So the result can't really be used for sort of like high-end applications, like for movies, for video games and stuff like that. The other big problem that we have at this point is that we still have really cool tech, but it's not really that clear how we can get all of this cool tech and turn it into viable products. And then another problem that I'm starting seeing right now is that some of these systems, like MusicLM, are not just self-contained systems, but they are what I call matryoshka systems, in the sense that they're based on other systems that embed other systems. And many of these like models are proprietary. So there is a huge barrier to entry to reproduce some of the best generative models that we have out there. And this point leads us to the final one, which is that given the high entry barrier that we have now for developing this massive generative music models, the risk is that smaller players like research institutions or startups may not compete against the big players. And the risk is that we're going to move into a sort of AI oligopoly where we have like the big tech companies like Google, OpenAI, which of course is backed by Microsoft, which have the necessary money, resources, and computational resources to work on these huge models, whereas the majority out there can't really compete. And this is like something that really worries me at this point. Okay, so now let's move on to the final point of the final section of this presentation, which is how's generative music transforming music? Well, and the other question that we should ask is who's generative music impacting? And for me, we can look at generative music having an impact onto listeners, to musicians, and media creators. If we take a look at generative music and listeners, we can see that one of the ideas is to enhance the listening experience. So in this case, we have AI system that generates music, and this music is directly consumed by listener. And some of these systems already started back in 1957 with the Illiac Suite, right? It's this idea that we can create music that will be consumed directly by listeners. I think Endel is doing a really good job in this niche because they're not really addressing kind of like high quality music, but more like background music or music, functional music like for relaxing or for sleeping. There are also like a lot of other examples in this particular category, like for example, Bloom, which is like this cool mobile app that has a generative music engine, and a listener can explore an ever-changing music world, and it has been created by Brian Eno. We also had other ideas, again, like in 2018, like for example, the partnership or like the collaboration between Dua Lipa and Jaguar, who came out with The Pace, which is basically like a piece of music which was recombined, remixed dynamically based on Spotify's listeners' profile. So you go to The Pace website, you sign up like with your Spotify account, and then they do a quick analysis, and based on that analysis, they create a new mix which is unique to you based off some music that has been pre-recorded with different instruments and that always has Dua Lipa's voice. I think like this is a terrific use case for enhancing the listener experience. So what to expect in the future? Well, I think we'll be seeing something like text to music models for social media, like in TikTok. So you have like your short video, and then you may want to add music to that, and you can use like a simple text to music model so that you can just like input, like share a musical idea, and then get a musical output that is like very customized like to your need. And we're also going to see personalized functional music, so based on mood, weather, so that it changes. And this idea of interactive albums and songs that change depending on the particular setting that you're in, your mood and stuff like that. I think like this is going to be like something really cool to look forwards to. Then we have generative music impacting musicians, and I think this is all about AI-powered tools for musicians. And here we are within the domain of human-machine interaction, and we can look at multiple use cases, like having some of these tools for inspiration, for enhancement, for facilitating, for example, for being more productive. So imagine you have like a melody system where you pass like a few melodic ideas, and then it develops like a whole melody for you. Then you can fine tune. Also, other systems you can directly collaborate with or practice with. And so some of these systems are going to be really killer for music education. An example of that is Schumann, which, if I remember correctly, was developed at Georgia Tech. And this is a jazz improvisation marimba player. You can see it here. So let me share the link once again here, because this is really like worth watching. Then we have also the Magenta Studio Suite by Google, of course, like the Magenta research unit within Google. And here, these are like all plugins that you can use within Ableton. One is called Continue, so you have a melody, and this melody will be continued by this model. Another one, for example, is called Drumify, so you have like your chord progressions or bass line, and Drumify will just add a drum section for you, which is quite cool. This is another really cool application or model called N-Synth, which is you should know this like very well, because like if you will compete within like the neural audio plugin competition. I mean, N-Synth is sort of like the big like daddy like a neural audio synthesis, really, right? And this is like a really cool synthesizer, and they also, if I remember correctly, yeah, they built like this hardware so that like the user could just like set it like and use like this hardware moving like from one point to another to change the quality of the sound. I'm sure you are familiar with this, but nonetheless, for those who are not, I'm going to share this link. So what should we expect in the future for generative music impacting musicians? Well, I think musicians will focus on high-level musical ideas, and then the boring details may be filled in by an AI. So yeah, indeed, the boring compositional processes will be offloaded to AI music tools. We're going to have AI music buddies to practice and perform with, just like human. They may be hardware, they may be software, but it's going to be like really cool, I think, like for musicians. And composers will have the opportunity to collaborate with AI tools to be more productive and also to get inspiration. Now, the final point here is generative music impacting media creators. And this is all of these tools which generate music for media. And here we have to create a distinction between linear media, so like videos, movies, or ads, and interactive media like video games, VR, AR, and apps. Boomi is this like cool startup company that you can use just like to create like instant music and share it literally like with the world. And it's overwhelmingly used also like by content creators like to create music like for their videos, for example. There are a bunch of other companies that are doing this. But if we were to look at what's expected in the future, I think like that AI will take over composition for music for videos and ads. I mean, like sort of like all that music that's very functional and it's not really that high quality, probably AI will have a say there. And at the same time, and this is like the sort of the coolest thing for me, AI will enhance composers who score for interactive media, for example, for video games, VR, and AR. This is like a really cool use case, I believe, because it will be possible for a composer to just provide a music idea, and then the actual implementation will be provided by the AI. So depending on how, for example, a video game changes, then the music will go in a direction rather than another one. And finally, we have AI generated music for social media. Yeah, we already saw this for listeners, but this will obviously impact also content creators like YouTubers, but also TikTokers. Okay, some of the generative music blockers that we still have today. As I said, music quality is more or less there sometimes, but not really. And I think there's still quite a lot of suspicion from markets and people towards AI and AI doing creative stuff, even though this generative AI revolution is sort of like kind of removing that blocker for sure. And there's a lot of inertia to change. This is like definitely true if you are talking to traditional companies like music labels. So, but what are in the end the promises of generative music? Well, I think on the one hand, it's music democratization for people and users, consumers. Of course, this doesn't mean that they will become professionals, as they haven't, as Instagram hasn't allowed people to become professional photographers. But at the same time, these are tools that will allow people to express themselves and their creativity to a certain extent and have an impact to the music generated. At the same time, and this is the part that is the most exciting for me, I think that generative music will extend what musicians can do right now in all directions, from composition to like the audio quality, sound qualities that they can generate and this kind of stuff. And this is like really exciting. So to wrap it up, generative music should extend what's musically possible, but it shouldn't replace what humans can do already. Okay, So that was the presentation. I hope you like enjoyed it. Like I'm gonna take like questions if there's time for that. But before we get there, I just wanted to say like 2 quick words about the Sound of AI Accelerator, which as I said like at the beginning, it's an initiative within the Sound of AI ecosystem. So this is a startup accelerator that's focused only on music AI, audio AI, and speech AI. So if you want more information, you can go to the website here. You have like all the information on, yeah, I also have like a video where I present most of the information, which is relevant for you. The dates are from April the 11th all the way to July the 2nd. And we accept individuals who are going to form startups, music AI startups, and we're going to teach them all they need to do. We're going to give them like really cool mentors, and they're going to get like industry connections and of course like exposure to investors, and all of this is for free. These are like some of the mentors that you'll have, and I have the honor to also have Josh as one of the mentors for this program.
Woohoo!
Yeah. Cool. And so let me just share this final link with you, folks. And yeah, and if you want to apply, or just know that applications are open and they will close March the 15th. If you want to keep up to date, like with what I do, the Sound of AI, of course, like it's my YouTube channel. You can easily find me there. And these are my contacts in case you want to reach out. So just feel free to take a picture, to take a screenshot here. Okay. So yeah, that's it. I hope it wasn't like too long or too boring, but I really wanted to give a sort of like overview of where we come from when it comes time to think about generative music and where we're going. To hope like I was able to pass that. Cool.
Yes. Thank you so much, Valerio. There are plenty of questions, some questions that are relevant to this talk, some questions that are a little bit more talking about the competition, but I'll see if I can successfully divide those up. So we actually have a question from George regarding your accelerator. It says, the question is, can one not apply if they have, so I'll read it word for word and then we'll see if we can interpret what he's saying. One cannot apply if they have already formed a team, started a company, and got funding. What about a solo practitioner, existing company, and bootstrapping? So I guess the question is, does the person, if they've already got started, are they still able to participate in the accelerator?
Of course, they are able to participate, but as individuals, because the idea is to create startup companies there. So if you're a solo developer, for example, but at the same time you are interested in joining up with sort of joining forces with other people and creating a startup company there, then of course you are free to participate, but otherwise no, it doesn't make sense because the point is to create new startups. Yeah.
Great. Okay. Tugrul asks, I think he says, I think most of the music nowadays is based off of past knowledge of music. I'm not a pessimist, but do you think AI can create a groundbreaking new genre of music?
So this is an incredibly interesting question. Now, so in my research during like when I was doing like my PhD, one of the sort of like more philosophical directions I went into was this idea of thinking about creativity and, well, I should say like rethinking creativity. Now, we define creativity or a piece or an artifact to be creative if it's novel on the one hand, and on the other hand, if it brings value to someone. Up until now, we've always been the evaluators, right, of the artifacts that we've created, right? Because there wasn't really like other agents that could create like creative stuff. Well, that's not entirely true because we still have animals animals, for example, birds, which have their own musical languages in a sense, or whales even, right? And they have their own musical societies in a sense. But now we have AIs. And so I was sort of like reflecting on the idea that if we change the evaluator, for example, if we were to create artificial musical taste or artificial intelligences, it could be cool to have agents, AI agents, that sort of like drive the development of musical styles, but not having like our way of evaluating music. I think like this could sound like as a quite sort of like weird idea, but I think like there's something interesting in there, which is like that these models may be able to sort of like explore ideas as if it was sort of like evolutionary algorithm, a genetic algorithm, right? They would have like their own fitness function, their own musical taste, and evolve. And other agents, like they would evolve their compositional style. And so if you have like a musical taste that's sort of like farther apart from our musical taste as humans, but still like it makes a little bit of sense, it may be the case that these models may create some new genres that are kind of like unheard of. And most of them probably will have like zero value for us, perhaps a lot of value for them because their musical taste will be sort of like tailored for that particular genre. But there may be sort of like edge cases where we find some new interesting sort of like intersections where what's interesting for them at the same time may be interesting to us as well. So you run these models wild, you hear the result of what they create, and then you decide as a human whether it makes sense or not. In that sense, you could use these models to simulate music generation, music society, really, and then take back like what makes sense for you. So perhaps in that way, yes, we may see new genres through AIs.
Fantastic. Wesley asks, is there a way to combine the two approaches to generating music, symbolic and using the audio itself?
Symbolic and audio. Up until now, in the majority of cases, you either go audio or you either go symbolic. But there are like some papers that I've read back in the day, which were trying to sort of like use kind of like symbolic, or at least like inject a level of music symbolic representation within audio models. And that is like definitely like a very intelligent and smart idea to explore, I do believe, because it will allow you like to lower the dimensionality of audio, which is really, really big. And so it's difficult to create to create like long forms that have coherence. Related to that, but it's slightly different, it's also like the types of techniques that you use. So right now, all the buzz is on deep learning models, but we are completely ignoring the heritage that we have from symbolic AI. And with symbolic AI, you're able to inject a lot of music knowledge within your models. And that is extremely important to have something that makes sense beyond a phrase level. In that respect, this is also like another line of research it's not super hot right now, but I feel it should be, and it will be soon, the moment like we start having like less buzz around deep learning, which is neural symbolic integration, which is basically like taking neural models and combining them with more symbolic approaches like generative grammars or like expert approaches, and trying like to combine the two and getting like the best of the two worlds.
Excellent. Tugaril asks, do you think there will be any innovations using AI on top of Xenaxis, like probabilistic music and other avant-garde, and what other avant-garde composers have done? Do you feel that there will be any differences?
Yeah, of course. I mean, Xenakis wrote some incredible music, I believe, using also like some probabilistic approaches, but they were like very, very simple approaches, and they were like probabilistic approaches. So, and the music that generated was kind of like most of that type of music was kind of timbre driven, really. So it really didn't have that sort of like more traditional structure where you have like a melody, you have a rhythm, you have a chord, a harmonic content, and all of that. In order to develop something like this that's a little bit more traditional, but which at the same time can be pushed in an experimental way, you need to have more control. And a simple probabilistic approach can only bring you so far. So having more sophisticated AI approaches will definitely improve on a simple probabilistic model that works fantastically well for Xenakis type of music or Ligeti type of music, but you can't transfer that to, I don't know, like music for, I don't know, like for video games or the majority of music games. Yeah.
Fantastic. Going back to a question about the accelerator, the man walk asks, is an account on LinkedIn a requirement to join, looking at the application form?
Yeah, we're gonna ask for that, yeah.
Okay, great. So I think there's one question that could be possibly for you, possibly for the wider group. And I'll just put it out there, and anybody that wants to chime in, please feel free to chime in. Craig Martin says, I see Guitar ML and other products model static snapshots really well of a distortion and amp cabinet processing chain. What would the best approach be for time-based effects like delays, reverbs, or vibrato?
Okay, so yeah, this is absolutely like not my within sort of my knowledge. So I'll just like leave it like to the other folks like to reply.
Okay,
I can give a quick answer on that. It's actually an open research question, I would say. So in my opinion, the majority of work in the neural effect modeling is focused on the kind of like distortion amplifiers and guitar kind of effects that are not time varying. And so actually an open research question as to what is the best approach there. And there are actually a number of PhDs in our lab at Queen Mary that are like asking that exact question right now. So if you're lucky, we'll have an answer for you shortly on that, but it's not yet been published. Yeah.
Fantastic. The other questions are more regarding the competition and things like that. So before I go into those, I wanted to say thank you very much, Valerio, for that fantastic presentation. And what I've done is, for anybody that's curious, I've linked the links that he gave throughout the talk below in the video description. So please feel free to go through those. Some very fascinating research happening in this area, of course. Thank you once again, Valerio. I know that you need to get going. Thank you. And once again, be sure to check out the Sound of AI's Accelerator. I will be a mentor for that. And there is a lot of great momentum happening. I know Valerio is going on tour throughout Europe at the moment. So yes, please join him and join his community over at the Sound of AI. Thank you very much, Valerio.
Yeah, thanks a lot, Josh, for having me here. Best of luck. Speak soon.
Thank you very much. All right, take care.